Hello, Internet. Today we're going to look at a new piece of software for representational learning algorithms for knowledge graphs. And it is called NodePiece. And I show you here a publication from arXiv from February 2022 that is also published as a conference paper to ICLR 2022. And it's called NodePiece by Mikhail Galkin from McGill University in Montreal, Canada. So, that you get the idea, I have here on the right-hand side in green, I've shown you a very simple idea presentation. In NLP, we had word2vec, and word2vec, you remember, we have an embedding for all words in our vocabulary. All words in the text, except the stop words and except some other words, we have encoded all the words. And in graph, a knowledge graph embedding, remember, we also have embedded all the nodes in our graph. Now then came transformer and the BERT model. And with BERT, we have a new tokenizer model. And this is the WordPiece tokenizer model. And as you can see, WordPiece and now the new NodePiece, you see exactly what we're looking at. If we now switch from NLP to a knowledge graph or a graph representation, NodePiece seems to be the new mode to have a compositional node tokenization approach for reducing your vocabulary size in large knowledge graphs. So you have a fixed size vocabulary of atoms and a simple encoder that will be able to bootstrap representation of any node from a sequence of your atoms in NodePiece. To have a look at this in detail, we have to look a short look at the paper. And of course, if you say, where can I apply this? We have it performs competitively in node classification, in link prediction, and in relational prediction task. And the authors show us that the NodePiece enabled model outperforms existing shallow models, having 70 times fewer parameters. And remember, the shallow models are more or less our all-word model or our all-node model. So this is some astonishing computational performance. And we will have a deeper look at this, at the methodology. And here we are. What I showed you here on the right-hand side, now we have published as a conference paper here on the left side. Maybe I even increase it a little bit more. So what we have here, a graph. This is our new NodePiece tokenization strategy. Let's say we have a target node in red. To have the perfect embedding and find our encoder, what we need is now, for example, 3 anchor nodes. And our anchor node is the blue one A1, the green one A2, and the purple one A3. And they tell, given 3 anchor nodes, A1 to A3, a target node, or a red node, can be tokenized into a hash of top k closest anchors, their distance to the target node, of course. And now it's a new group, a new set of relational context of outgoing relations from the target node. So whatever is an outgoing relation from our target node, you see here we have R1 inverse, R3 inverse, and R7, you have to make sure that we construct inverse relations that are added to ensure connectivity, of course, because we need this to be able to as an input to our encoder, so we have our target node. So this is it in very short terms. Of course, you have here details about the NodePiece vocabulary construction, about the anchor selection, about the node tokenization. If you want to have a look at it, I recommend this paper. It's really interesting. But if you just want to have a look at the code, I recommend here from Mikhail Galkin the GitHub NodePiece. It's public. And you have here NodePiece, computational and parametric efficient representation of large knowledge graph. This is the same idea. You have the updates And you have here the installation source. And if you're interested in the code, you have here, for example, for link prediction, we have here some code and some explanation, some benchmarks, but we are interested, of course, in pure coding. So let's have a look at this. And here you have is NodePiece tokenization now in detail, import torch, iGraph, Pykin. Maybe I do a little video on Pykin also. And here we have our class from NodePiece tokenization or tokenizer. And then you have a look at the code if you're interested how it is coding, but it is already done for you. A very interesting piece where you have high performance, you reduce your vocabulary size significantly, and then you just go on with your classical knowledge graph completion like trans E or rotational E or whatever. And they also tell us that it works great with graph neural networks. So what you do is more or less, and let's come back to this image, the advantages we have from an alternate tokenization behavior in BERT. There's this idea now with NodePiece that we can more or less transform from NLP now to graph embedding, to knowledge graph embedding with those NodePiece algorithm presented here in the paper and in the GitHub. If you have a look at the performance, it shows you that sometimes it even outperforms the classical model. This was it for today. I hope to see you in the next video.